Okay, so let's take a look at, here we're going to look at a couple of examples where we're solving area problems of parallelograms. Right? So let's start off with this example here. So let's say we have a parallelogram. Let's try that again here. Okay, so I have a parallelogram and we have that this angle here is 60 degrees. All right, and I'm given that this piece here is 4 units. And then this piece here will be 5 units. Okay, and that is all I am given, and I'm asked to find the area. Find the area of the parallelogram. Area of the parallelogram. Okay. Okay, so just based off the figure, I know that the base is going to be 9, right? If you look, if this part is 4 and then this part is 5, then I know that the base here is going to be 9. Now, what I don't know is the height, right? So this value is going to be the height. But I am given a piece of information that is going to help me find the height, right? So I know this is, so if this is the height here, so that's going to be a right angle, right? We have a, what's going to be a 30, 60, 90 triangle, right? If that angle is 60, this one needs to be 30. Okay, so that means from our previous section here, right, we have one of these special triangles, right? So the hypotenuse, if the side opposite the 30 degrees is 4, then that means that the side opposite the 60 degree is going to be 4 times root 3. Okay, so that's just our properties of our 30, 60, 90 triangle. So now I have all the information that I need to find the area, right? The area is going to be, again, area formula for a parallelogram is base times height, so which turns out to be 9 times 4 root 3, which equals to 36 root 3. Okay, all right, and then this will be units squared, okay? Whatever those units happen to be. All right, don't worry about simplifying that root 3. I'm looking for exact values, right, unless specified otherwise, but mostly exact values, so you can leave it like that. Okay? All right. Let's try a slightly different example here. So here, let's say that we have a parallelogram Okay, so I have a parallelogram, and I'm given that here the height is x minus 3. And the width here, the base, excuse me, is x plus 2. And I'm also told that the area is actually equal to 36 units squared. right? And I'm asked to find x. Okay. All right. So the area is 36, but the area is also, since it is a parallelogram, it's also the base times the height. In this case, area base is x plus 2. Height is x minus 3. All right, and then here let's do one more substitution. I know the area, so x is 36 equals to x plus 2, x minus 3. Okay, so now I have an algebraic equation here that I can work with. Turns out it looks like it's going to be a quadratic, so we have 36 equals to x squared minus x minus 6. All right. Okay, subtract 36, set it equal to 0, so subtract 36 from both sides, we get 0 equal to x squared minus x, this become minus 42. All right, so again, as always, given a quadratic formula works, I always like to check, can I factor this? And here, if I can factor it, it'll look something like this. I think I could for this one. All right, so I'm looking for numbers that multiply to a negative 42, so opposite signs, but add up to a negative 1. And I think here, that's going to be minus 7 and plus 6. All right, that satisfies both of those conditions. That last number will be negative 42. The two middle terms will add up to a negative 1. Okay, so now I can jump to my solution, x equals 7, or x equals to negative 6 from here. Okay, so here I'm going to take a look. So I have two values. Let me double check here. Again, always when dealing with physical quantities, do my answers make sense? And it looks like that negative is not going to make sense here. It does not make sense to have negative lengths. So I'm going to reject that solution, so I really have x is equal to 7 to be my only solution. All right, and that solves this type of problem here.